This is Australia, a place of extremes. On the east coast we have abundant rainfall with lots of black coal for the generation of electricity and for hydro energy generation. In the centre we have brown coal and liquid petroleum gas for the generation of electricity, but now we also are starting to use the energy of the sun and the energy of the wind to generate electricity. The question is how to store these latter two energies so they can be used when the sun isn't shining and when the wind isn't blowing. And it's suggested that pumped hydro energy store is the answer. There are two ways of doing that. One was open systems, which is the traditional way of doing it, and the other one is with closed looped pumped hydro energy stores. Having generated electricity by whatever method, we then have to distribute it. And here are the current major electricity transmission lines in Australia. Some of these transmission lines are completely private and they're owned by, for example, this orange one going through central Australia is a privately owned BHP electricity transmission line, and this green one here between South Australia and Victoria is an example of a high voltage direct current transmission which actually runs underground between the two states, and the other one in green is the high voltage direct current which goes under the ocean between Tasmania and the mainland. At the moment we have 3 pumped hydro electricity, and these are all open ones. Built was the one at Shoalhaven, and then we have the one on the Snowy Mountain scheme at Tumut 3, and then in Queensland we have the Wivenhoe. At this moment at Kidston in Queensland they are building a closed looped pumped hydro scheme, and finally at Hope Valley in South Australia we actually have a mini pumped hydroelectricity scheme, and we'll start looking at that particular example first. I'm in suburban Adelaide in Hope Valley, and behind me in this dry creek in Hope Valley we have behind me a man-made wall built in 1870s to store water, 4 years water for the city of Adelaide in 1870s. Adelaide has a dry Mediterranean climate and it only rains in the wintertime with brief showers, and so they built a diversion dam on the River Torrens and built a series of tunnels and pipes and aqueducts to bring the water here. This is the diversion dam on the River Torrens in the gorge in the Adelaide Hills, and water using the power of gravity was moved from there in the River Torrens across to the Dry Gully in Hope Valley, where they built this dam to contain the water. 4 years supply of water was the reserve that was created.
After that, with the growth of the city, the amount of water needed got to the point where they had to build a pipeline from the River Murray, from Mannum to the Adelaide Hills to store the water. That was started in 1949 and finished in 1955. Later, with the development of the city of Dry Gully, they decided to extend the pipeline up to Vista and then bring it down to a storage tank at another location here in Hope Valley.
This is the River Murray at Mannum, which has got an input into the pipeline with the pumping station just on the edge of the bank there, using electricity of the state system. The pipeline runs under the main road and now it comes up to the surface, and you can see it's a very dominant part of the landscape which citizens have to negotiate around, and what they do is have the pipeline dipping underneath the roads as it moves across the landscape. Here we come to pump station number 2, and the yellow lines are the power lines which are being used to supply electricity to the pumping stations. This is pumping station number 3. You can see the branch there. And now we come to the Millbrook Reservoir, where a lot of the water is stored as they place and then distributed to other dams such as the Para Dam. And we come to Vista, and then we come down. This is Vista, and we can see there a quarry which we'll discuss later on. And then it goes down from Vista. Here there's a treatment station for the water, and then it descends down the escarpment of Vista into Hope Valley to this micro hydro station, which we can see is labelled here in Google Earth. And the electricity is generated using the energy which was stored when it was pumped up the hill, as now coming down the hill. And then we come across to see the view from Grand Junction Road at Hope Valley. And this is the street view.
On Grand Junction Road, Hope Valley, and behind me you can see the escarpment of the Adelaide Hills at Vista, and just here behind the fence, behind that green wall, is this micro generator built in 2003 with the help of the hydroelectricity of Tasmania. So from the hydroelectricity micro generator, electricity is then brought to this substation for distribution into the normal network. The advantage of generators and hydroelectricity are often synchronous with the AC, so they're very useful devices in any electricity generation system using AC.
So in this view I have switched off the yellow of the electricity power lines, and the white is the actual Adelaide to Mannum pipeline with its pumping stations. The interesting thing is, if we look at this and we look at the elevation, we can see that Mannum itself is at quite a low level above sea level, and then when we come to pump station number 2, there's a plateau at this point, and then we get up to the higher parts of the Adelaide Hills, and when we come to Vista we can see that at this point there's a very sharp descent down to Hope Valley, and so the energy which is used to pump the water up the hill is being retrieved as the water rushes down from Vista, the hydro station there. So this is an example of pumped hydro energy. Hydroelectricities are normally installed where there's lots of water available where there's a reservoir high in the mountains or the hills, with another reservoir or river in the lower section of the mountains, a short distance away. And with pumped hydro, what you're doing in the daytime is using excess energy from somewhere else to pump water uphill, so that later on you can allow the water to be released to come down and generate electricity when you want it. So it's really a pump during the daytime pumping up, and a generator in the night time when the water's coming down. That's fine if you're in a wet area, but in dry areas like South Australia, the upper Flinders Ranges, what you can do is cart some water to a location on the countryside and have a man-made reservoir high in the hills with another lower reservoir in the flat land below the hill. Much of Italy is like South Australia and Australia in that it's a dry Mediterranean climate. Midway between Rome and Naples is the town of Caserta, which has got the Dominicca pumped storage hydro, consisting of 2 man-made dams. It is a typical closed cycle power system consisting of 2 reservoirs with a capacity of approximately 6 million cubic metres each and a relative height difference of 500 metres. If you look at the upper dam, this is in a dry gully, and it's done by cut and fill, so that only one wall has been created using the dirt from the centre section and the back section, so that it's very economical to build this dam high up in the mountains where there's no natural rainfall. Its key feature is the proximity to the areas of both Rome and Naples, which enables it to generate electricity in the grid in central and southern Italy. The plant is not far from the route of the 380 kilovolt power line, which is the transmission backbone of the country. Now look at the lower dam. This dam is on flat country and it's often called a turkey's nest. In the flat plains of the US, the turkeys, when they want to make a nest, have to create a hollow, and the way they create a hollow is to dig a hole out, and the dirt from the centre of the hole is then to make the walls around the nest. And if we go down to ground level, we can see that it just consists of a dry wall, and meanwhile the community around are completely unaffected by the fact that there's a closed system, because the water inside this dam is not used by the community at all. It's there just for the purposes of being pumped up and down the hill. During the day, water's pumped up the hill, and at night the water comes down the hill. And so here we can see the pipes coming down the hill into the turbines, and the turbines themselves are underground, similar to what's happening at Hutt Valley in South Australia with the transmission grid above. Construction began in 1979 and was completed in 1990, and the 4 reversible hydroelectric power units were gradually turned on between 1990 1991 and 1994. Dam on flat land, slope, a rise and a depression. Here we can see construction of one of these at Nettle Hill water storage facility. It was designed and constructed by Catcom and is a 147 megalitre lined and covered water storage facility for the Victor Harbour and surrounding districts located in the southern Eyre Peninsula, South Australia, west of Mount Compass. Earthworks for the 9-month project involved 100,000 square metres cut fill using equipment such as scrapers and graders. It was designed by the client's SA Water Corporation, and the water storage measures 150 metres by 150 metres and is 15 metres deep. The water storage is synthetically lined to avoid seepage and it's a floating cover to prevent evaporation of the evaporation and contamination of the water. So that is what it looks like now in real life. This is the actual dam in action with a floating cover, and we can see in the moment that we look across the Hindmarsh Valley, looking down towards Victor Harbour. And this is an example of a turkey's nest dam which exists in South Australia. This is the Nettle Hill water storage above the Hindmarsh Valley, and just nearby is the original reservoir, Hindmarsh Valley Reservoir, which was too small to supply Victor Harbour and Magill with the growing population, and instead they decided to take the water from a reservoir further away at Maiponga to supply the water. And you can see that this particular reservoir has a concrete arch dam to supply the water on the Fleurieu Peninsula. The Fleurieu Peninsula has a wetter environment, so that solar energy would not work very well down here, but we do have the Starfish wind farm on the coast just above Jervis Bay near Maiponga, which was the first wind farm in South Australia. The Australian National University has looked at turkey nest sites. That's where you're using dry gullies, and then on the plain you create a holding dam. If we look at the smaller ones, these are 2 gigawatt hours lasting for 6 hours. There are none in South Australia, but a few, and we're looking for the red ones. In South Australia we have 4 and a few red ones on the east coast at 15 gigawatt hours for 18 hours. We have just above Port Augusta an orange one and some red ones on the east coast at 50 gigawatt hours, a number again with the turkey's nest, and at 150 gigawatt hours of some very good prospects on the east coast of Australia, up in Queensland and down in Victoria. Again, at 500 gigawatt hours, there are a number of red ones in and around the ACT and up on the border with New South Wales and Queensland. And finally, at 1,500 gigawatt hours and 60 hours, we have 3 sites, one around Canberra and 2 on the border of Queensland and New South Wales. And finally, at 500, there are none. Here are some of the infrastructure, the power lines, wind farms and solar which we have in the northern Spencer Gulf section around Port Pirie, Port Augusta. And the issue here is the amount of energy generating. At the moment, the South Australian government is trying to get private companies to invest in things, and we can see that one of the issues is distributed PV. And unless we use batteries of some kind, then there's going to be a waste of money and energy because of the fact that we aren't doing it. And so by using pumped hydro energy store, using covers to protect the water from in the environment, we can actually build a economy using the energy of the sun and the wind.